Dear students, a very good afternoon to all of you. So today we will be doing the master theorem. What it says, master theorem is Pn. Actually, master theorem is used to calculate the complexities, time complexities. This is the shortcut method I told you. For the iterative approaches, we can use this master theorem. But for the recurrence, recursive functions, we cannot use the master theorem. Right? Friends, good afternoon to everyone. So today the topic which we'll be doing is Master's theorem. So this is Pn is equal to A T n by B plus Fn. Master's theorem is nothing but it is used to analyze the time complexity of any given equation which we will be deriving. Fine. And we will be seeing the constants there A and B and we will be solving if it is applicable to them. Theorem. So this is Pn is equal to A T n by B plus Fn. Master's theorem is nothing but it is used to analyze the time complexity of any given equation, which we will be deriving. Fine. And we will be seeing the constants there, A and B, and we will be solving if it is applicable to them. Then where Fn is theta of n raised to power d and d is greater than equal to 0. Now, if Fn is given to me as n square, what is theta? It is theta n raised to power 2, and here d is greater than equal to 0. From there we conclude that my relation is having value n and its power is greater than 0, which is equal to 2. For that we have three cases applied. Case 1, Tn is equal to theta of n raised to power d. D we will get the power if a is less than b raised to power d. Then case 2, Tn is equal to theta of nd log n if a is equal to b raised to power d. Then Tn is equal to theta of n raised to power log a base b, sorry, if a is greater than b raised to power d. Now we will be looking at the examples of each of them. So we have Tn is equal to 4t n by 2 plus n. Here a is equal to 4, b is equal to 2, and fn is equal to n or n power 1, and therefore it gives me d is equal to 1. Now, which case is applied? We have to check from this condition. 4 is greater than b raised to power 4 is greater than b, a is greater than b raised to power d. That means third case is applicable. Third case is applicable. Fine. So what does it say? Tn is equal to theta of n log a base b. So you will write theta n. Tn is equal to theta of n. Log a is log 4 n raised to power log 4 base 2. Okay. Then log 4 base 2 means log 4 will be divided by log 2. What it gives me? It is equal to log of 2 square divided by log of 2, which will give me 2 log 2 divided by log 2. Fine. This cancels out and this gives me 2. That means substituting the value here, I will get theta of n. This value is now 2. Substitute this value of 2 in equation 1. So you will get n square. That means the complexity of this equation will be n square. Complexity of this equation would be n square. I repeat everything. Tn is equal to 4 Tn by 2 plus n. A is equal to 4. B is equal to 2. Fn is equal to n raised to power 1 because n power is 1. From there we get d is equal to 1. Now this relation will be applicable since a is greater than b raised to power d. 4 is greater than 2 raised to power 1. So we will write directly, we will use this equation. Tn is equal to theta of n log 4 base 2. Actually, this is n power log 4 base 2. So log 4 base 2 is equal to log 4 by log 2. And we can say that log 2 square by log 2. Then we can write 2 log 2 by log 2 and we will get 2. So here n's power is 2 because we have calculated the value of log 4 base 2 as 2. So this is going to be theta n square. Now for case 2, we will be doing one more example. Suppose this equation is given to you 2t n by 2 plus n. Now a is equal to 2, b is equal to 2, and fn is n power 1. So d is equal to 1. If I compare this equation with this, you have to compare every time this equation with this. You will get a as 2, b as 2, then fn as n power 1, and you will get the value of d is equal to 1. Now you see a and b are equal, or a is equal to b power d, that is 2 is equal to 2 power 1. So that means this relation satisfies the second case. So you will write theta is equal to, sorry, Tn is equal to theta of n, d is 1, and log n. Fine. So it gives me that the complexity of the given equation is n log n. I will tell you how to, I have told you how to get these equations. Today we will be doing merge sort. From there we will get this kind of equation and we will apply the master theorem there. So this is your second case. So case 1 we have done, case 2 we have, case 3 we have done. Now we will do case 1. Now let's assume that the equation which is given to us is Tn is equal to 3Tn by 2 plus n square. Very simple. A is equal to 3, B is equal to 2, Fn is equal to n square, and D is equal to 2. See, equation given to you is 3n n by 2 plus n square. A is equal to 3, B is equal to 2, Fn is equal to n square, and D is equal to 2. Now, here A is see now here A is less than B power D because 3 is less than 2 power 2. Here A is less than B power D, that is 3 is less than 2 square. So 3 is less than 4. That means this case 1 will satisfy. And the complexity would be theta of n raised to power d is 2. So this equation will have the complexity of theta of n square. So this equation will have the complexity of theta of n square. I repeat, Tn is equal to 3Tn by 2 plus n square. Here A is equal to 3, B is equal to 2, Fn is equal to n square, and D is equal to 2. So A is less than B raised to power d, that is 3 is less than 2 raised to power 2, where 3 is less than 4. So case 1 will satisfy. Case 1 says Tn is equal to theta of n raised to power d if A is less than B raised to power d. So this case has satisfied. So we will directly write Tn, that is time for complexity for the given equation, will be theta of n square. So today the first topic which we were about to do was master theorem. So we have completed with that. Now second is your divide and conquer strategy. Then we will apply the divide and conquer strategy in merge sort, and later on we'll find a time complexity analysis of the merge sort. So What does divide and conquer approach says? In divide and conquer approach, the problem in hand is divided into the smaller subproblems. Then each problem is solved independently. When we keep on dividing the subproblems into the smaller subproblems, we may eventually reach a stage where no more division is possible. That is, the atomic smallest possible subproblems are solved. Then the solution to all the atomic subproblems are finally merged in order to obtain the final solution. Now, what does it say? This is the given problem A, B, C, D, E, F, G, H, I, J. Let's suppose this is a problem. So we have divided the given problem as it was large into uh, supposedly 10 subproblems. Fine. Then we have found the solutions of each of these sub-solutions of each of these subproblems. That means capital A, B, C, D, E, F, G, H, I, J are the sub-solutions of the subproblems. Finally, these sub-solutions are merged to get the final solution as A, B, C, D, E, F, G, H, I, J. First of all, we will divide, then we will find the solution to each of the subproblems, and then we'll be combining all the sub-solutions to form the final solutions. Now, divide and conquer has these 4 steps. First, you have to divide the problem into subproblems, then conquer subproblems by calling recursively until the subproblem is solved, combining the subproblems so that we can get the final problem solution. Then we have to do the complexity analysis, time and space complexity analysis of the given problem. So these are the following approaches which are based on divide and conquer, and we'll be doing merge sort, quick sort, and binary search, which is based on these strategy, that is divide and conquer strategy. Okay. So we will be doing this right now. For example, we have been given a problem, that is problem which is very large, which is very large. We have been given a problem which is very large and it cannot be solved as it is. Then we will divide the problem P1, P2, P5, and so on up to Pn into different subproblems. We will divide the problem into smaller subproblems so that it can be easily solved. Then we will find the individual sub-solution for the given subproblems. So S1 is the solution for the P1, S2 is the solution for the P2, and S3 is the solution to the S3. S3 is the solution to the P3, S4 for P4, and S5 for P5, up to so on Sn. That means these are the sub-solution of the smaller subproblems varying from S1 to Sn. Varying from S1 to Sn. Now, finally, we will combine all these sub-solutions to get the final solution. Okay. Now, how these problems are divided and how these are solved. The question is this. To get the final solution, we need to club all the sub-solutions. But we want to solve these problems. DAC says, divide and conquer says, all the problems should be recursively solved. Means what it wants to say, suppose if major problem is of sorting and we have been given 10,000 numbers to sort, then we will divide that list into say 100 elements of each. That will be my problem 1, problem 2, problem 3, problem 4, and problem 5, and up to so on. That means these problems will also be of the similar types. These problems will also be of the similar types. That means if bigger problem is of sorting type, then all the sub problems will also be of the sorting type only. Because if this problem can be solved with any solution, suppose generalized solution X, then P2 will also be solved with the same algo X. For example, we have made the algo for sorting that is called X for this problem. Then P1, P2, P3, P4, P5, and Pn, they will be solved using this algo X only. and only then we will be able to combine its solution because they are following the same algorithm. Fine. So divide and conquer is the strategy which is used to design the solution, which is used to find the solution for the bigger problem, whichever is given to us. And finally, we will combine all the solutions, that is S1, S2, S3 up to Sn, to get the final solution. That means we actually modularize our approach. We are dividing the problem into number of sub problems. Same algo which we have designed for the main problem is used to solve the sub problems. Then we will get the sub solutions. Then we will combine the solution to the given problem as final solution. Now, if we generalize this approach, what does it says? DAC stands for divide and conquer. If problem is small, then give the direct solution. Then give the direct solution. And if it is large, else divide the problem into P1, P2, P3, but they must use the recursion. Divide the problems in such a way that they must use the recursion, or they should call the main function again and again, or they should make the call to itself again and again only, and we will solve the problems using the recursion only. Then, and if recursion cannot be there, if you cannot apply the recursion to the all the sub problems, then we are not supposed to use this strategy because it is based on recursion only. Then apply DAC, that is divide and conquer. Suppose if P1 is also big, then what will you apply? DAC, that is divide and conquer. Then you will again break up P1 into, suppose, PA, PB, PC, and you will club its solution to give the solution to the P1. Fine. You will find the solution of A problem, then B problem, then C problem, and you will finally get the solution of S1. This is how you will do. And this is again recursive. These problems P, A, B, C should again be recursive problems. That is, they should make the function call to P1 itself again and again. So apply divide and conquer to the problems P1, P2, P3, and P4, and finally combine the solutions, that is S1, S2, S3 up to so on, to get the final solution. To get the final solution. So this is what divide and conquer says. That means recursion is the part of divide and conquer, and it is used to solve the problem recursively and get its solution. And finally, all the solutions are combined to get the final solution. Divide means dividing the problem, conquer means find the solution, combine means to combine all the sub-solution to get the final solution. Now, I told you in the PPT that there are the various application of this divide and conquer. So first is merge sort. Merge sort. This strategy is basically used to combine two sorted lists. There are two arrays or two lists which are already sorted. Suppose this is an array A, this is an array B. Okay, they are already sorted, you will merge them. So this is called merge sort. Okay, so we are going to merge the two sorted array, or combining the two sorted list into the third list, that is C will be equal to A plus B, or it will have the elements from both A and B but in the sorted manner. C is a array which will have the elements from A and B both, but in sorted manner. Okay. So I will write the algo here. Then we will apply the algo to get the C list. Merge. Before merge sorting, we will do the the algo for the merge only. A, comma B, comma M, comma N. Then, so now what we have to do is, I think algo is in the readable form. So I explain the algo, then we will apply the merge sort. So merge A, comma B. Here A is the array and B is also the array, which is of length M and N respectively. Here A and B are the arrays which are of length M and N respectively. If I say the length of array M A is 4, that means M is equal to 4, right? And here the length of array is 3, so that means N is equal to 3. Length of array A is 4 and length of array B is 3. Okay. Now we have taken three variables, I is equal to 1, j is equal to 1. So this is I is equal to 1, j is equal to 1. Now k is the location. K will be the location where we are going to insert the elements. Okay. So for I, see, I is equal to 1, j is equal to 1, k is equal to 1. Now, while I is less than equal to m and j is less than equal to n, here I is equal to 1, it is less than equal to 4. And j is 1 less than equal to 3. So both the conditions are true. Okay. So both the conditions are true. You can write like this, while I is less than equal to m and j is less than equal to n. You can consider it like this, but we don't write in the code. Now, what do you have to check? If A of I is less than B of J. So compare A of I is less than B of J. That is, compare A of 1 is less than B of 1. That means 2 is less than 5, condition is true. 2 is less than 5, the condition is true. Therefore, C of K is 1. So that means at one position in the array C, we will have 2. We will have 2. Okay. Now, C of K plus plus, that means now it will come to the second position since we have not given any element here. We will be providing it element. Now again, we will be doing I plus plus. So I plus plus is 2. 2 is less than 4 and J is less than 1 is less than 3. 2 is less than 4 and 1 is less than 3 because we have not taken any element from J. So it is again 1 only. So 1 is less than 3. Now compare AI is less than BJ. Is 8 less than 5? No. Is 8 less than 5? No. So what we will do is C of K plus plus is equal to B of J. That means 5 will go to the second position in K. 5 will go to the index 2 in C array. At first position, first index element 2 will be there. At second position, element 5 will be there. Increment K. So we have entered the third location. Now, J plus plus, J is equal to 2. Now again compare AI with BJ. That means A of 2 is less than B of 2. 8 is less than 9. Yes, true. So C of K, that is C of 3, would be equal to 8. Okay. Now increment I. So I becomes 3 and J becomes 2. Again compare A of 3 with B of 3. You have to again compare A of 3 with B of 3. So A of 3 is 15 and B of 2 is 9. Again compare A3 with B of 2. So 15 is less than 9, condition false. So at location 4, since we have implemented K here, you will get 9. You will get none. Now, increment j by 1 because we have taken the element from the B. So this becomes 3 and I is 3. So now compare A3 with B3. 15 is greater than 12, yes or no? 15 is greater than 12, yes or no? So 15 is not greater than 12. So this else part will satisfy. So at location 5, we will have 12. At location 5, we will have 12 because every time the k is also incremented. Now, you have done 5 elements, 2, 8, 5, 9 and 12. They are in their corresponding position. As you can see, this is in the sorted manner. This list A was in the sorted manner, B list is also in the sorted manner. Now we have combined them into the C in also the sorted manner. Now what about this element 15 and 18? Where they should go? Now what about these elements 15 and 18? Where they should go? For that we have taken one loop here. For I column, that means wherever you have left the I. If there are more elements till the length of M length was 4, we have taken only 2 elements. That means we will take 3 and 4th element. So put them into the AL. So 6 would be 15 and 7 would be 18. As it is, they will be picked and appended to this array, that is C at location number 6 and 7. At location 6 and 7. This is how it is done. For example, if it would have been here, if they would have been here, 15 and 18 in B array. Now the length is 5. So for that we have this loop for J, since J is used to traverse the elements of the B starting from the first position till the end. So wherever you have left the B, suppose you have left the B at 3. So 4th, 5th location will be occupied by 15 and 18. Whatever is left, they will be occupied here at 6th and 7th location from the array B. And finally, we have got this final array of how many elements? 1, 2, 3, 4, 5, 6, 7 elements. You will get the final array. Now, what will be the complexity of this? It would be equal to theta of m plus n. What would be the complexity of merge sort? Average complexity would be theta of m plus n. Why? Because you have taken the arrays of m and n length respectively. So both the times will be taken into the consideration while traversing through array A, which is having the length of m elements, and array B, which is having the length of n elements. So you will take both the lengths into the account of the arrays A and B respectively, and hence you will say it is equal to theta of m plus n. Okay. Now there is one more concept which is called n-way merging. It is not confined to only 2 lists. You can have n number of lists. So suppose they are A, B, C and D. 4 lists are being given to us. Fine, they are having the elements, right? 4, 6, 12, 3, 5, 9. Then you have 8, 10, 16, 2, 4 and 18. Now, what is the strategy? Suppose this is 4 lists which are being given to you. So you are going to basically perform the merge sort. First of all, you perform the merge sort on A and B, perform the merge sort on C and D as we have done for the 2 lists. Okay. Then you can combine the results into the final stage. Suppose the output of this is supposingly L1, that is list 1, and the output of C and D is L2. Then you combine them to get the L3. L1, L2, L3. Okay. The output of A and B would be L1, C and D would be L2, and this is L3. Using the same algo, we will be doing it. See, for example, this is I, this is J, this is K, and this is N, supposingly. Fine. So you compare all the elements at the first position, what you will get? Output is supposingly K array. So at the first position, you will get this. First compare all these elements. You will get 2 here. Okay. Then this will be incremented. Suppose this is big array A. It is O. This is big array O. Then I, J, K, K and L. Now what happens is this is incremented. Now you are here with these comparisons. Which is smaller? 3. So you will take 3. Then since J is taken away, so this has gone, this has gone. Now what you will be doing? 8 and 4. So compare this thing and this thing. That is I is equal to 1, B is equal to 2, C is equal to 1 and D is equal to 2. Now first this is 4 and this is 4. First 4 which will be popped out, it will be the location number 1 of A. So this is 4. Okay. Now increment A of I by 1. You will have this 6, 5, 8 and 4. Now D will be popped out. So this is this way. Minimize minimal number which is in this list 6, 5, 8 and 18 is 5. So this has gone. Take this. Now you will get 6 because this is a minimal number between 6, 8, 9 and 18. So this is gone, this is gone. Now you have left with this comparison. So you will get the 8 here. This is gone. Now you are having 10 number here. So which is smaller? 9. Then you will get the 10. Then you will get the 12. Then you will have the 16 and 18. Then you will have 16. Then you will have 18. This is how 4-way merging is performed. Now you can apply it to n number of lists using the same strategy. Okay. Now I'll show you how you will combine the same list by using the 2-way merge sort. 4, 6, 12. Then you have 3, 5, 9. Now combine this. Compare I with compare J. You will get 3. Then you will get 3, 4 and 5. Compare 4 and 5. You will get 4. Now 4 gone, 3 gone. Compare 5 and 6. You will get 5. Now compare 6 and 9 because I will be equal to 2 and J will be equal to 3. Comparing 6 and 9, we will get 6. Now comparing 9 and 12, you will get 9, then you will get 12. Okay. Now for C and D, let's do the same thing. Apply this algo here. While I is less than equal to M, that means it is equal to 3 and this is equal to N. Now this is 1. This is 1, means both the arrays are of same length, that is 3 and 3 respectively. Then compare 8 with 12. AI with BJ, 8 will come. Then I plus plus, compare 10 with 12, you will get 10. Then again I plus plus, compare 12 with 16, you will get 12. Then compare 14 with 16, compare A of B of J with A of I, that is here J value is 2 and I value is 3. Compare BJ with A of I, you will get 14, then you will get 16, then you will get 18. Now combine this. Combine these two sublists using the same method. See, this is the list 1 and this is list 2. Now we will get the merger of this. How many elements? 6 elements in both the lists. So M is also of 6 and n is also of 6. Compare I of 1 with j of 1. You will get final sublist as L2, which is first element would be 3. Okay. Then 2, compare 2 with j of 1 because j has not been incremented. 4 is less than 8. So you have 4 here. Then you have 5. 5 is also less than 8. It will also come here. 6 is also less than 8. Come here. Then 9. See, these are the elements which have gone. First 4 positions have gone. Now I is equal to 5 will be compared with j is equal to 1. So it is greater. Now 8 will come here. So this is gone and j is incremented by 1. So j is equal to 2. So I is equal to 5 and j is equal to 2 will be compared. Then what happens? Which is smaller? This one. I value 5 is smaller, so 9 will come here. Then I is incremented to 6. 6 is having 12 and it is compared with J2. J2 is smaller, so in L2, J2 will go, that is 10 will go. Now 12 is compared. This is I is equal, J is equal to 3. So 12 is compared with 12. AI is smaller than equal to, yes, of course it is equal to. So this 12 value will be gone. So now how many elements are left in J? 14, 3 elements. So according to this loop, for J is less than equal to n, J plus plus, C of K plus plus will be equal to of B of J. So you will write 14, 16 and 18. This is how you will perform the merging of all the sublists. Fine. So that means recursively we have called it on L1, L2 and finally on L3. That means if my problem was large, 4 lists were given to me, I have divided into the 2 list. Then call the same algo for providing the solution. I have given L1 and L2 as a solution. Then finally L1 and L2 are combined to give the L3. That is the final solution to the given problem. Your problem was there. I divided into 2 lists each and then tried to combine it. Okay. There are multiple ways by which you can perform this merging. Like you can do this way, L1 and L3, then L2 and L4, combine these to get L5 and L6 and finally get the L7. There are multiple ways to perform the merging and sorting on the given list. You can do it in n-way merge sort. Okay, so this is how n-way merge sorting is performed. Now we will have a look on two-way merge. Now we will have the look on two-way merge. This is very, very interesting. Two-way merge. We are given 10 elements in no particular order. Fine. Fine. What does two-way merge say is that although you are saying it as a combined list or an array of 10 numbers, but I will consider as a 10 list of 10 numbers, 10 arrays of one number each. 10 arrays of one number each. Fine. Now what happens? I will assume that each element is a array itself and it is sorted. And it is sorted. Now, because a single element is always sorted. So we will take the group of two elements, 9 and 3, 7 and 6, because we have to perform the sorting. Then 5 and 3, take the elements in two lists, two numbers list. First it was individual element, now we are taking two element in a single list. So 2 and 1, then 18 and 15. L1, L2, L3, L4 and L5. Fine. Now what we will be doing, this is your first pass. Second pass. Combine L1. Sort this and combine it into this password. First of all, combine L1 and L2. 5 and 3 remain as it is. Or you may combine L1 and L2. So combine this 3, then again 3. Combine L1, L2 and L3 after sorting it. 3, 3, 5, 6, 7 and 9. Here 1, 2, 15 and 18. So L4 and L5 combined. Now get the solution in the third pass. 3, 3, 5, 6, 7, 9. Oh, sorry. I have to sort it down. 1, 2, 3, 3, 5, 6, 7, 9, 15 and 18. Okay. So this is after merging you are getting. How many elements are there? 10 elements. How many elements are there? 10 elements. For example, we don't have these two elements. Now what will be the answer? See, I show you how it will be done. 9376, 53, then 21. Okay. Combine this 3, 6, 7 and 9. Combine this 1, 2, 3, 5. Then combine these, you will get 1, 2, 3, 3, 5, 6, 7 and 9. See, how many elements are there? 8 elements. How many passes are there? Second pass, third pass. In third pass, they are all going to be in the sorted manner. Fine. So initially there were 8 elements. You broke them into the 4 lists of 2 elements each. Okay. Then there were 4 lists. Then you have broken down or combined them into the 2 lists of 4 elements each. That after that, again you divided it by 2 and you form the single list. So how many times it was divided by 2? 3 times. That means 8 divided by 2 raised to power 3. Okay. That means what you will get, which is equal to, this is equal to log 8 base 2. If you are taking log 8 base 2, which is equal to 3 passes. That means whenever you are taking the log of number of elements in the list, it will give you 3 passes. For example, in previous, you have taken the log of log base 2, 10 elements were there, it was also 3 point something. That means round off, it will take 3 passes to actually get sorted, and you will get the merged solution for this particular two-way merge. In 3 passes, you will get the, see, how many levels are there? First level, second level, and third level. For how many elements? 8 elements. Even for 10, we were doing the same. Right? So, first of all, 8 elements, individual elements were there. You divide it by 2, you make them the group of 4, list or 4 arrays which were having 2 elements each. Then you have combined them, again divided by 2. 4 divided by 2 is equal to 2 lists, which will have 4 elements each. Then you have again divided by 2 and you have sorted the entire list and merged it to get this list only. Fine. So this is called two-way merging. And log 8 base 2, you will get 3. That means for n elements, when you take the log of that, then you will get the number of passes which would be required to perform the sorting and merging on the given list of elements. Now merge sort algo. Then we will apply the merge sort algo. So what does merge sort algo says? What we have to do is we have to write the algo for it. So merge sort L comma H. We have to check whether the static index is lower than the final index. Okay. If L is less than H, then you will call merge sort. This is a recursive call which is being done. Then we will call the recursive sort. First of all, calculate the mid, which is equal to L plus H by 2, low plus high by 2. Then call the merge sort on low comma mid till mid. Then call merge sort on mid plus 1 comma high. Then merge sort low comma mid comma high, and finally this will be closed. Fine. So this is how you will do it. Now let's take an example of it, then I'll show you. 9375. The elements, I'll be taking 8 elements in a list and performing the same thing. 9, 3, 7, 5, 8, 6, 6, 4, 8 and 2. These are the elements which are there in the list. 1, 2, 3, 4, 5, 6, 7 and 8. Fine. Now find the midpoint. Mid will be equal to the first condition if lower is less than high. 1 is less than 8, condition is true. L is less than H, that is 1 is less than 8, condition is true. Now what we have to do is find mid. Mid is equal to L plus H by 2. That is 1 plus 8 by 2, which will give me 9 by 2, that is 4.5. But I am supposed to take its round integer part only. So I will divide the list from this thing. 9, 3, 7, 5, 6, 4, 8, 2. So we are left with the two lists. 9, 3, 7, 5. Then second list would be 6, 4, 8, 2. Okay. We have been given two problems, L1 and L2. Now, this is L1, this is L2. Now find the mid for each of them. See, 1, 2, 3, 4, 5, 6, 7, 8. Here, 1 is less than 4. This condition is true. Here, 5 is less than 8. This condition is again true. Mid is less than high. Sorry, low is less than high. 5 is less than 8. Here, 1 is less than 4. This is low. This is high. This is low. This is high. This is low and high of list 1. This is low and high of list 2. 5 and 8 are low and high of list 2. 1 and 4 are low and high of list 1. Now, 1 plus 4 is 5 divided by 2. That is 5 by 2. It gives me 2.5. So, I am going to break this list from this thing. Here, I will be breaking this list from here. That means again, I am getting how many lists? 4 lists. 9, 3, 7, 5. This is my L1, L2, 6 and 4, then 8 and 2, L3 and L4. Fine, we are getting 4 sublists. Now again, you have the mid 1, 2, 3, 4, 5, 6, 7, 8. So 1 is less than 2, condition true. 3 is less than 4, condition true. 5 is less than 6, condition true. Then 7 is less than 8, condition true. Find the mid. This will be the mid. 1, 2, 2 plus 1 is 3, 3 by 2 is 1.5. So first element will be separated. Third element will be separated. Fifth element will be separated. And 8th element is separated. So we have how many individual lists? 9, 3, 7, 5, 6, 4. Sorry. This is their individual element 4. Then 8. Then you have 2. How many individual lists are there? L1, L2, L3, L4, L5, L6, L7. Now divide and conquer, which I've shown you in the first PPT, that we have to keep on dividing these smaller sub problems where we will reach a stage where no more division is possible, or you may reach the atomicity. So these are the atomic elements now. Now there is no more division possible on the individual elements. We cannot divide these elements into further, we cannot make the divisions on these atomic elements. Now what we have to do, now we are going to sort it and combine it. How we will be sorting it? Now I will move upwards. Now the array will be towards the upside. So combine these two, you will get, sort will be 3 and 9. So you will get L1. Combine L3 and L4, you will get 5 and 7. Combine L4, L5 and L6, you will get 4 and 6. Then you will combine. After sorting, you are going to combine. So you will get 3, 9, sorry, 2, 8. This is 2. 3, 9, 5, 7, 4, 6, 2, 8. After combining, you will be getting 4 sublist. Okay. See, merge sort, low mid you did, mid plus 1 high you did. Now merge sort L, M and H. So you are now combining them. Now combine it. You will get 3, 5, 7 and 9. Dividing and conquer is applied. Now you are merging the solution or combining the solution in the sorted manner. 2, 4, 6 and 8. Finally club these all. Club these all, you will get a final subsorted list, that is 2, 3, 4, 5, 6, 7, 8 and 9. These are the sorted combined solution of this merge sort. After performing the merge, you have done the merge sorting. So in this way, this is being done. Okay. That means what you have is, if I make the block diagram of this, you have the elements from 1 to 8. Divide n by 2. You have taken the elements 1, 4. Then you have taken 5, 8. I'm talking about the indexes here. I'm talking about the indexes here. Then you again divide it by 2. Here it is n by 2 by 2. That is n by 4. You have divided this list into 1, 2, 3, 4, then 5, 6, and 7, 8. Again, you have divided by 2, that is n by 4 divided by 2, that is n by 8. So you have got the 8 different sublists where no more division is possible. Then you started sorting the elements and clubbing the sorted elements into the final sorted array. This is how you did. Okay. Now let's have the complexities. I will solve it with the help of master theorem right now. So I'll write the algo again and then we'll find the sorting of it. Algo merge sort. You will write L, H. Then you will write if L is less than H. Find the mid. Mid is equal to L plus H by 2. Then merge sort L, mid. Then merge sort mid plus 1 by high. Then merge sort low, mid and high, and you close this. Fine. And see how much time it is going to take. Merge sort L to H, that means total elements would be n. So this is T of n. Mid calculation will take 1 unit of time. You are sorting here till mid, that means you are sorting the half of the element, which will take T of n by 2 times, because half time will be taken to sort the half number of elements. Again, this was mid plus 1, that means you have divided the list into 2 equal halves. So it is Tn by 2 into, plus Tn by 2. Now again this is for n elements. So that means it will take n unit of time. So hence the equation would be Tn is equal to, hence the equation would be, I'm writing the equation here. I am using the iterative method to calculate, or master theorem to calculate the complexity. So Tn will be equal to Tn plus Tn by 2 into Tn by 2 will become, if I add both of these, it will be equal to 2Tn by 2. One, because constant we have to ignore, and Fn is n. Merge sort is being performed on n elements. So you will write 2Tn by 2 plus n. According to master theorem, A is equal to B, A is equal to 2, and B is equal to 2, and Fn is equal to n power 1, and D is equal to 1. Now here second case will apply, because here A is equal to B power D. Okay. So 2 is equal to 2 power 1. So what is the answer? That is Fn is equal to, just wait, I'm doing it. Fn is equal to n raised to power d log of n from master theorem, where A is equal to B raised to power D. Therefore, it is theta of n raised to power D log n. So D power is 1. So the answer is n log n. In best case also it is n log n, and in worst case it is also n log n. Fine. So we have to take the compare, because we have to divide the list every time. So we have to take the log n, and for n elements we are doing. So it is why this is big O of n log n, and this is your this thing. The worst case comparison would be n log n. Okay. So how, this is how we have got this thing. So thank you so much for this session, and if you have any queries, we will. You can send me your doubts on WhatsApp, or you can call me anytime. So thank you so much.